Oh, whoops. All right, welcome to class, everybody. Hope everyone has been staying safe and warm in our very cold, windy, snowy day today. Let's see. And also, I hope you're all looking forward to the 3-day weekend that we have coming up. So no class on Friday. You still have lab tomorrow. Feel free to use that time to work on Project 4, as well as the lab that's due tomorrow. One small thing is that on Friday the 18th, so next Friday, we're also not going to have class. I will provide a short video introducing the topic for that day, but I can't be in class, and so, now you know. You don't have to physically be here on the 18th, and on your own time you can watch this video about file I/O in Java. We won't use that until our Lab 13 anyway, so even if we had class, you would probably forget it and have to relearn it for that lab. So no class that day. And trying to think if are there any questions that I can answer about Project 4 right now? Hopefully everyone saw the note about, for the capital gains part of it, it is possible to do pretty slickly. So you just need one queue. You just add stuff in, and then when you sell, call your DQ. You don't have to add stuff back in. You don't have to be looking at the contents of the queue. You only need to be looking at what comes out. So if you can figure that out, hopefully that will be satisfying. But as long as you can make it work using a queue, then you will get full points. Okay, so I actually wanted to just review amortized analysis from last time, because I know that it can be confusing, and I just want to give the high-level summary. What do you need to know for this class? So last time we talked about dynamic arrays, where when we have underlying our list, our array list, we have an array, and when it fills up, we're going to double the size of that array. And how do we do our runtime analysis of that operation of adding? In the slides here, they're calling it push, but how do we analyze the runtime of that operation? Because most of the time, it's really simple, our push, right? Clearly it's constant time. We're just updating a value at an index. But every once in a while, and that is in this picture, every once in a while, it's slow. And so on one hand, if we're talking about worst case, well, what is the worst case of calling our add method? Well, in the worst case, it has to do a lot of work, right? It has to do one of these. But a lot of the time, it doesn't have to do that much work. And so it's not magic. It is amortized analysis that gets us to being able to make the statement that for a dynamic array, the amortized runtime of our add method is big O of 1. So this, on a quiz, if you were asked what is, and I would really make sure to say this would be the amortized runtime, what is the runtime of the add method in an array list? It is still big O of 1 when we use amortization. However, and again, I would try really hard to make sure that it was clear that when we actually do a resize, hopefully my handwriting is at least somewhat legible. When we add and we have to resize the array, it actually is taking time proportional to the that new array size, because we have to copy everything in, we have to initialize that array. And if we weren't doing the resize, it's big O of 1. So these are the concepts that you would need to understand for this class. Why? I wouldn't ask you to explain why this amortized analysis is big O of 1, but if you want to understand it, it's that we can charge this long runtime, we can charge the bigger runtime, we can say there are enough calls to add that don't take very much time to account for the one that takes a long time. And as long as we're doubling, that's always going to be true. So that is what I want you to understand for amortized analysis for the purpose of this class. And I realized that on the lecture page, I had linked to not the whole book's description. So now we actually have a 3-page PDF. And so you can see a really careful discussion of what does it mean to charge the longer runtime to the smaller runtimes. And the book has a more detailed description of that. So that is available to you if you want it. You can also come to office hours and talk about it anytime. So, cool. Any questions on that? Great. So then let's move on to today. So we're going to get to iterators, but just setting ourselves up, I also wanted to point out some useful methods for working with list data types in Java. So let's see. Let's actually go over to Eclipse. So I'm just working in my day 30. So that was on Monday. We looked at the array list, this array list.java, and we also looked at the list interface. So when I talk about lists, I'm talking about things that implement the list interface in Java. And so the main one that we're going to focus on is array list. So there's a built-in Java array list, but here we happen to have our own array list code. So yeah, let's work with some array lists, some lists, and see some of these really useful functions that already are built into Java. So let's see. Let's actually start with converting suppose you have an array and you want to change it into a list. Could totally make sense. So that would come from, so let's make an array. So it's going to be of type string. I'm going to call it R. And if you remember, if I already know what's going to go in my array, and I just want to initialize it with some elements, I can do that. So I'm just going to put some strings in here. Alice, Bob, Charlie, Daryl, and Effie were the ones that I thought of earlier today. And so, okay, I've got this array R, and I want to convert it to a list. So I am going to use the list data type. So first off, okay, let's see if I'm going to call it names. So I had my array R, and I'm going to make a list of names, and it's going to be an array list. Oh no, I'm going to use the arrays. Why? Arrays dot, oh, it really wants to. I'm going to import some stuff so that maybe it will stop autocorrecting for me. So I'm going to import java.util.arrays, because that's where this method's going to come from. I'm also going to import java.util.list. Oh, no, I'm not going to do it that yet, because this list, so, okay, in this package, so day 30, you probably can't see it, but we can see it, at least we can see it here. So these are the files that we've got in our day 30 package. We've got list.java, which is our interface list. And we've got ArrayList.java, which is the book's implementation of ArrayList, right? And it implements the list interface. So I've got all these open. So this one's ArrayList. And we can see it's implementing this list. So just reminding ourselves, because in the description of this class says we're going to cover advanced Java. So we're advanced Java users, writers of software in Java. Let's say I make an array list of type string, and I just make an empty one. Why do I not have a... Okay, we won't do this. We're going to use the arrays.toList as list method, and we're going to pass in our R. And why? So, one confusing thing that's going on right now is that we have our own list interface, but Java also has a list interface. And this asList method is returning something of type list. But it's not our list, right? Like our interface list here is something we wrote, but that is not interacting with the Java list interface. But I do want to ask, so the Java list interface, it's definitely an interface. Like let's go to the Java documentation. I'm going to look for Java 17 API. Oops. And I'm going to look at the list, java.util.list. And we can see, okay, it's an interface. And remember, what's the difference between an interface and a class? Anybody remember? Sure, yeah, go for it.
Interfaces, you have to send its methods out to be used in other functions and stuff. It's abstract.
Yeah, it's basically like the most abstract, like abstract classes are kind of in between classes and interfaces. Interfaces, we can't instantiate an interface. We just say that a class implements an interface. However, and I just didn't want to took me a while to get there because we have to actually use the correct list interface. But why is it, like, why can I write why is this line okay? Why is this Java code fine? I just told you I can't instantiate a list because it's an interface. And we can double check that. List, it's an interface. But it kind of looks like I am. So why can I actually do this?
Instantiating a list per se. Instantiating a list of strings.
Ooh, okay. So it's true that I'm passing in a type parameter of string, but I still, that's not quite it.
It's just an array. What is that? Equals array.asList. So it's like it's an array, but you're going to treat it like a list.
So arrays.asList is a method from the arrays class. So the arrays class is where we got toString and things like that. I see a hand. So let's just look up what does arrays dot, okay, we're going to look up java.util.arrays, and we're going to see the method as list. Oh, okay, it's right here. Okay, so I thought maybe that this would tell us that it was returning us specifically an array list. But basically, the answer here is that we can, what we're seeing again, like we saw earlier, is polymorphism. So list, basically, what we're actually being returned is some instance of a class that implements the list interface. So if there were no classes that implemented the list interface, we couldn't do that. But what this is going to return to us is it's returning us an instance of a class that implements the list interface. And that's why when we saw before how we can declare an object to be of a type that is, as long as it's a superclass of the type, then we can declare it. But anyway, long explanation of me not wanting you to, or me wanting us to have an opportunity to review interfaces, polymorphism, etc. But okay, let's take a look. Let's just double check this thing. It's real. So let's print out names. Great. We're able to print it. Names. It is has type list. And I also wanted to show that we've got some nice functionality in the collections. So coming back to the lecture. So in java.util collections, we also have a bunch of useful methods. So I think I actually have a link here. So you could follow this link and see all of these static methods down here that can be useful when you're working with, say, array lists. And so, for example, as long as I import java.util.collections, then I can use, say, collections.max, and I'm going to pass in names. And so, can anybody guess what I'm going to print out now? If I run this again. Yeah, okay, so Alice could be the max, but actually it's the min. So here we're just using a lexicographic ordering, so an alphabetical ordering. And so Alice is like the smallest. This might actually be different if we could try, sometimes, my guess is that, what happens when Alice has a lowercase a? Yeah. So actually, this can trip you up if, when the lexicographic ordering of strings, if you just go straight, you don't do anything special, the lowercase letters actually come after the uppercase letters, which is definitely can be confusing. But we'll go back. Okay. So FE is the max, and you can see, so collections, we didn't have to specify that this was over strings or anything like that. Like this collections.max method is also going to work over any list of any type that we pass in, as long as it's a list type. Similarly, we could have collections.min, and now we're finally going to print out Alice. Great. How about if I do collections.shuffle and I pass in names? Does anybody have a guess what this shuffle method's going to do? Yeah.
Move around the position of elements, isn't
yeah, it's gonna basically randomly shuffle this list. So we didn't know about this, and we were using arrays, not lists, but in all of our projects and labs where we've needed random lists of integers, another, at least in terms of random ordering, if we just put a bunch of integers in and then we shuffle them, we could get, if I needed a randomly ordered list of all the numbers between 0 and 100, I could put them in a list, just use a for loop, start from 0, end at 100, and then call shuffle on it. So indeed, we got a random ordering of our list. Okay, so now let's actually make an array list of our own using our array list from our array list file over here. I'm going to call it ints, and it's just going to be, it's going to start off empty. I'm going to call the constructor, and then I'm just going to use a for loop, and I'm going to put some ints in there. And I think I can just add, what does our list have? Okay, let's add them, I'll just add them at the front, or add them at the back, so that, what is I++? And I'm going to print this out. I wonder why. Add, it's the order. Okay, so our list, we pass in the index first and then the element. So I'm going to add at index 0, and I'm going to add I as my element. And so now I expect this to be a decreasing list because I'm always adding at the front. And indeed it is. Okay, so I have this array list, and so now I want to talk about iterators. So let's go back to the lecture page. So iterators are a really important design pattern in software. You're going to see them, you see them in Python, in all the languages that I regularly use have iterators, Python, C, C++, or at least C++. I guess I don't know about C. Definitely not C because it doesn't have objects. So C++, Python, Java, they all have iterators. And they can be the thing I think that's hard to understand about iterators is why do we use iterators? So let's kind of see what it is, and we'll make sure that we get to why do we have them. So an iterator, it just scans through our objects in some sequence. And so the basic methods that an iterator object should have are has next, so are there any more? So we're scanning through a sequence, are there any more? And also, next, what is the next one? And we already have used an iterator a lot, which is scanner, which is an iterator over some input, an iterator over a string in particular. And so we can see if we take a look at the java.util.scanner class, look at that. It's implementing the iterator interface. So I can click there, I can read about it, and I can also see, I thought maybe we could see, okay, so scanner definitely implements in the iterator class. or the iterator interface. So yeah, so scanner, we know about scanners. So so an iterator, it's a class, and let's see what it looks like to actually implement the iterator for ArrayList. So it's actually already in the, if you got the code from Monday, you downloaded the code from Monday's lecture, where we have our array list, and this, if you scrolled through this, you would have noticed that there's actually a nested class inside this array list, and the class is our array iterator, and it's implementing the iterator interface. And in fact, this is the Java iterator interface. It's the same interface that Scanner is implementing. And so what does this iterator class do, and when do we even use it? That's probably a better place to start, is where do we actually use this array iterator class? Well, I'm just going to use find in this file, and it's tiny even for me, but where we use it is in this iterator method, which when we call, it returns us this class. So how do we use this? Let's go back to our demo. So I've got ints, which is of type ArrayList, and so I can call, I want to make an iterator of integer. So I'm going to probably need to import java.util.iterator. And this is going to be whatever is returned to me from int.iterator. Let's see. Oh. Let's not do this over our ints. Let's instead do this over our names. So I'm going to I've got iterator of type string. I'm going to call it it, and it's going to be names.iterator. So remember, names is a list type object, but this is going to demonstrate to us what do iterators do. Well, let's print out what is returned to us by it.next. I guess, does anybody have any guesses about? Well, actually, it's going to be hard to guess because we are shuffling. So let's not shuffle anymore. Okay, I'm no longer shuffling the names. So I made this iterator it from my names list, and now I'm calling it.next. Anybody have any guesses what I'm going to print? Yeah, exactly. Just the first name in the names list, and that's what we see that we're doing right there. And if I did it again, we would just print, our iterator. It's just scanning over our list. And so if I call next again, I'm going to print out Bob. Feels exactly like our scanner. We also have the it.hasNext method, and so in this case it's going to return true because we've still got the next is Charlie, so we do have hasNext is true. There is a next. Any questions about that? Pretty simple, pretty basic. So how is this implemented? Let's go back to our nested class. So, well, all we're doing is we're just maintaining this index, and so the index is j, and we are just returning data at j, and then we can have the plus plus in there. That just means that we execute, we're going to do the plus plus last. So yeah, this is a post increment. So really, and then in here we have this removable field, and that's because we can optionally have our iterators also support removal. And maybe if we have time at the end of class, we'll get into that. But, okay, so here's a question. Like, are we doing anything in our iterator? Are we doing anything that we couldn't just do as a method of our class? Like, is there anything about this that couldn't just be done? Like, could J just be a field of our, rather than having a whole nested class, could J be a field of our array list class? Like, if I really wanted a next method, could I do that? Yeah, at least I'm seeing some nods. I mean, I could just have next be a method of my array list, or what's really the point of my iterator? Well, it's to be able to walk over this list. Couldn't I just use a for loop or something, right, to walk over the loop? And really the answer is yes. Like, I could do those things. And so what does an iterator get me? Well, how I think about it is that as long as we have these iterators, we have this common thing that if we write code that is performing some task, like for example, our max or our min or our shuffle. We have the same code that's working for any kind of list. And in fact, it's not just any list. This max is going to work over stacks. It's going to work over anything that's in the Java collections framework, which is also a good thing to look at. So if I'm in the Java API, I can search java.util.collections. So one thing you'll notice, actually just collection, singular. So collections was the class that we're getting these helpful methods from. Collection is an interface, and collection is, let's see, a bunch of things are collections, like stacks, queues, lists, all collections. And so by defining these iterators, we are giving a common way that we can walk over any of these types, be it a list, be it a stack, be it a queue. And so rather than having to define, say, the get method, like a stack doesn't have a get method, right? Like, by definition, we can't get at an index in a stack. But if we just define an iterator, then I can pass an iterator that came from a stack into, if I have a method that takes in an iterator, I can pass a iterator that came from a stack, I can pass an iterator that came from a list, I can pass a scanner, and they're all going to be able to work with that because it's guaranteed to have the methods that an iterator has. And so iterators are very basically a really good example of object-oriented programming principles, where we've abstracted this idea of walking over something, next, and we've made it the same for anything that implements the iterator interface. So, maybe one last thing just to see how do we use iterators. So, you remember the for each loop, right? So if I wanted to walk over my names list, I can say for a list I have for let's see, string name in names, right? And I could do something with name, right? So really what's actually happening is these for each loops are implemented under the hood. They are using iterators. So under the hood, what's actually happening is we're getting an iterator over names, like this one. So I'm going to just delete this. I'm going to move this down. So under the hood, we're getting this iterator over names, and then we're doing, we'll just make it while it dot, what do you think I need to put in here? If I want to recreate a for each loop using an iterator, what? And I remember I just have two methods for my iterator. Yeah. Yeah. So while my iterator has a next, do whatever with, how would I get name? I would get name equals, so let's say I wanted to print out name is, and then I'm going to print name. So if I want to do the same here, first I need to get name, let's say. And so can someone else tell me how do I get the name? Yeah. Yeah, exactly. And let's see why. Oh, I guess string name. And so this is just an example of these for each loops. I love using for each loops. Very, very simple, and we can use them for anything that implements an iterator, the iterator interface, or the iterable interface, in fact, specifically the iterable interface. And really, yeah, under the hood, they're relying on the existence of an iterator for the class. Okay. All right. Well, that is all that I wanted to cover today. And yeah, after this, we are going to move on to searching through collections like lists. And so, yeah, feel free to come up if you have questions. Have a good 3-day weekend. See you next week.